Hi, and welcome to the first and only video for section 10.8. Now, the order is a little bit out of order compared to the book, right? So we just got done with 10.1. We're now jumping to 10.8. We'll then do 10.9. Got to give credit where credit is due here. Math instructor from UNLV, Caitlin Cox. She recommended this order, and I have to agree with it. We just got done doing systems of linear equations with two variables. So 10.8, we start doing, or well, we do systems of non-linear equations. So linear equations had x to the first power, y to the first power. With these nonlinear equations, doesn't have to be the case. Maybe we have a line and a circle. We're trying to figure out where do these guys intersect. Or maybe we have a parabola and a circle, and where do those guys intersect? Point being is that they don't have to be just lines. It could be a line, could be not any line at all, like I said, a parabola and a circle. But what we're going to do is solve it with our elimination method. Video 2 from section 10.1 was on the elimination method, and that's what we're going to do for our nonlinear equations. So let's look at an example. Let's say we want to solve x squared plus y squared is equal to 100, and 3x minus y is equal to 10. So in this case we have what? Well, remember, this is our equation for a circle, right? Standard form. The center is at 0, 0. Our radius is 10. So if I was to draw this, so let's say this is 10, negative 10. We have this circle here with the center at the origin. And this guy, what? This one is a line. So if I solve for y, so I take that back. So depending if we have a line as part of our system, we can use the substitution method. If we don't, we're probably going to have to rely on the elimination method. This one has the line, so if I solve for y, I get negative y is minus 3x plus 10. So divide everything by negative 1. You get y is equal to 3x minus 10. So this one then is what? This is the equation of a line, y equals mx plus b form, with our y-intercept down here, which happens to be this part of the circle. And then we have the line that heads up this way. So what we are doing when we are solving these systems of nonlinear equations, just as before, when we had two lines and they were crossing at some point, when we solved it, we found out what was that point of intersection. Well, now, because I have a circle in a line, I actually have two different spots. I have this point and this point that I'm trying to figure out. So to solve this, I can use substitution method. I just solved for y, so I can now plug this back into my first equation. So I get what? I get x squared plus y squared, which is 3x minus 10, all equals 100. And this is a square because it's y squared. So I have to square the 3x minus 10. So now expand this out and combine my terms. So I get what? I get x squared. This guy is really what? It's 3x minus 10 times 3x minus 10. So if I FOIL it, I get plus 9x squared minus 60x plus 100 equals 100. So now I have one equation with one variable. So if I subtract 100 from both sides, I got to solve for x here. I get what? X squared plus 9x squared is 10x squared minus 60x, and the hundreds ended up canceling out, so this equals 0, right? So now what? I can divide everything by 10, make life easy on myself. So I get x squared minus 6x is equal to 0. Factor out an x, so I get x times x minus 6 is 0. And now I can use zero property rule. So that means what? That means x is equal to 0 and x minus 6 is equal to 0, which means x is equal to 6. So I knew I was going to end up with two possibilities, right? One value for x, and another value for x to give me two different values for y. So now plug that back into either equation. I'm going to use the second equation here. So when x equals 0, I get what? Y is equal to 3 times 0 minus 10, which is 0 minus 10, which is negative 10, which we expected, right? Because we knew this was a circle with radius 10, and we knew that one of the intercepts was at 0, negative 10. So one of my solutions is x is 0, y is negative 10, which if we write it as an ordered pair, would be 0, negative 10. When x equals 6, so same idea, I plug that in for my y equation. I get 3 times 6 minus 10. So that's 18 minus 10, which is 8. So when x is 6, y is equal to 8, which gives me the ordered pair 6, 8. Which means this point here is equal to 6, 8. So it kind of makes sense. That puts me in the first quadrant, which is where I should have expected my answer to be. So those are my two solutions. 0, negative 10 is a solution to this system, and 6, 8 is a solution to this system. All right, so that's one example. If you need to pause, go back through, follow any of the math, that's fine. Otherwise, I'm going to erase this. We'll look at another example. All right, in this example, we want to solve 3x squared plus 2y equals 26, and 5x squared plus 7y is equal to 3. So in this situation, we have what? We have an x squared and a y to the first power, an x squared and y to the first power. So those are what? That's two parabolas. So basically, I have one parabola that looks like that, another parabola that looks like that, and what I'm trying to do is figure out what are these 2 points where they intersect. Now, we have our options. We can either do substitution or elimination. So I'm going to try to get rid of this x squared piece. So you could try to eliminate the y's if you want. You could multiply this one by negative 2 and this one by 7. That's fine. Either way you go about it is fine. I'm just going to eliminate the x squared term. So I just get y equals something. Then I'll plug it back in and figure out what my values for x are. So this first row, I'm just going to multiply by positive 5. And that gives me what? 15x squared plus 10y. And 26 times 5 is 130. So I get 15x squared plus 10y is equal to 130. So now with this one, I need to get the x value to be a negative number. So I'm going to multiply by negative 3. So when I do this, I get negative 15x squared. Whoops. X squared. 7 times negative 3, so minus 21y. 3 times negative 3 is negative 9. So now when I add down 15x squared minus 15x squared, gone. 10y minus 21y is minus 11y. And 130 minus 9 is 121. So divide both sides by negative 11 gives me that y is also negative 11. So negative 11 times negative 11 is 121. So that's my value for y. So in this parabola here, this is at negative 11 units down is where these guys are crossing. But now I need to figure out what are the two x values that correspond to that. So I plug it in. Again, you can plug it into either one. I'll just plug it in the first one. So I get 3x squared plus 2 times y, which is negative 11, is equal to, not 24. Doing some math in my head here already. Sorry, 26. So I get 3x squared minus 22 is equal to 26. So I'm going to add 22 to both sides. So you get 3x squared is equal to 48. So divide both sides by 3. I get x squared is equal to 16. And now this is where you have to be careful. If I'm solving an equation and I have an x squared, this means what? This means x is equal to plus or minus the square root of 16. So x is equal to plus 4 and minus 4. Two possibilities, which we knew, right? We had to have an x over here in the negatives and an x over here in the positives. So that means my solution set is x is negative 4, y is negative 11, and x is positive 4, y is equal to negative 11. So again, two answers for this system. And that's what you're going to do. If it's a parabola in a circle, same idea, use your elimination method. If it's a line in a parabola, so we have some parabola, we have a line cutting through it. What are these 2 points? That one you'll probably use substitution method. You can solve for y if you're not going to get some really crazy fractions. And substitute it into your parabola equation, solve for your variables. So that's it. Just the one video, as I said, for section 10.8. Come on back, we'll look at section 10.9.